Hello, my name is Joe Higgins, and for my CS224U final project, we will look at machine translation from natural language to computer code. Computers typically use highly structured languages to interpret commands from humans. Programs written in structured computer languages are expressions of a human intention that can also be expressed in natural language. For example, software companies document product requirements as natural language instructions for software developers, who then translate that natural language into machine-readable code. As a result, this can be approached as a machine translation problem. Below are examples of human descriptions of code in natural language on the left, with their Python implementations on the right. Our project will use card texts from Magic the Gathering, a human playable card game, as our natural language input. We will also use each card's matching Java implementation from a digital version of Magic called Xmage as our target output. There are about 15,000 examples in our dataset. Here is one example of a Magic card and its Java representation. This card is a Prodigal Sorcerer, a 1 power, 1 toughness, blue human wizard creature that can tap to deal 1 damage to any target. On the right is its Java implementation. We see structure in the Java. It has self-referential strings, Prodigal Sorcerer, at various points. It has the types creature, human, and wizard. It has power and toughness of 1 each, and the damage ability is expressed in a fairly readable format below the comment. Note there is a lot of boilerplate, as Java is a verbose, heavily templated computer language. The model tries to learn relationships between sequences of numbers as seen in the top 2 boxes. These numbers represent token indexes in each language's vocabulary. The project thus far has focused on experiments on tokenization of raw text. Tokenization is not as simple as splitting on every word or every character. We can aid in our model's understanding of the text by providing structure via tokenization. Some of the experiments we've implemented so far that have increased performance include creating multi-word expressions, replacing self-referential strings with common symbols, giving numerals with special meanings such as power and toughness their own symbols, limiting the max length of the sequences, and varying vocabulary size. The model we use to learn the mappings from sequence to sequence is an encoder-decoder LSTM. It is a common technique for learning sequence-to-sequence models. The model learns an encoder that takes a variable length sequence to a fixed length vector representation, and learns a decoder that takes a fixed length vector representation to the desired output variable length sequence. Our initial results are well below the state-of-the-art BLU4 benchmark that was created by a team at Google DeepMind in 2016. By looking at a few sample outputs, the model seems to be learning the preamble boilerplate well, but then in the substantive middle of the Java, it repeats common tokens over and over to minimize its loss. What's next? This is our current prioritized list of experiments. Immediately, we plan to add unique start and end tokens. Then we can work on our network architecture by adding an intention mechanism that should hopefully address the repeated token problem. If time permits, we will explore the other ideas below. Thanks for listening.